Okay. So, McLean and everybody else is everybody, not all of you are, you need to, can all of you hear me? Dylan, can you hear me? Are you,
Yeah, I can hear you. I can
okay.
hear you.
Okay, so I think you have to have your, you have to be unmuted, is that right? Or you have to engage in the video. So Eric, are you doing that? Eric, can you hear me? Eric?
Yeah.
Okay, so you got to leave that on because I'm teaching, so you're listening to me, and if you can't hear it, it doesn't
Gotcha.
work. Okay, I don't care if oh, Donna, there you are. Okay, great. I like it when you show yourselves at least at the beginning, so I know what you look like and who I'm talking to. So that's great.
Hey Patrick,
Hey, what?
this is Alec. Can you see my video, or is it just a black screen?
Just a black screen, Alec.
All right. Yeah, something's not working. I might have to leave and come back. Like
Okay.
restart my computer or something. So
Okay.
I might be a couple minutes.
Okay, before you go, let me make an announcement to everybody. It's a repeat announcement that I'm recording these and I'm putting these recordings. It takes me a few hours after the class, they have to process. And so, I don't want to stay up till, midnight or 1 waiting for this. So in the morning, it's all processed and I transfer it to the announcement page on Canvas. So every Tuesday morning, the night before, Zoom will be on there. So if something happens like Alex saying and he gets screwed up and he can't get through or he can't hear any number of things, or you're working that night, make sure you go back and look at it at that announcement page, okay? I've said this before, so most of you probably know it, but I just want to make sure. Okay, go ahead, Alec.
All right. Thanks.
So does anybody have any problems? I mean, related to this class. If you live in the world today, you've got problems. I know that. So are all of you working or are some of you staying home during the day?
I'm
Who's
working.
staying home? Anybody staying home?
I am.
God, that's hell, isn't it? It was a great idea 6 months ago, but I'm through with it, God. I never thought going shopping for food would be the high thrilling point of my week, All right. And you're all keeping safe, is that right? Wearing masks. So I ride my bike to, this is the last thing I want to say about the virus. I ride my bike along the cliffs above Coal Oil Point, in IV there. And I stop and I watch the waves and the islands and then I ride home. Nobody in IV wears a mask, very few people. And, IV spiked a little bit in the last few months because of that. But I'm telling you, when you look at the data on the news, it's in some places it's rounding off a bit, but every day it's going up numerically with no end in sight. And that's because people aren't distancing or wearing masks. That's almost a foolproof way to stop it. So I'll say this one last time tonight. I'll repeat it later in the year. But you guys are most of you are pretty young and healthy from the looks of your screens. So you could probably get through the virus okay. But if you bring it home to your parents or older friends or sick friends, they're going to bite the bullet, I mean, that's the thing. It's not you guys. You guys are healthy. But, people that aren't in school go home to their homes and they have parents and grandparents at home. Or some of you are living at home now, so you have older generations in your homes. So just be real careful and think about them, okay? All right. So if everybody's knows the system we're doing, well, hey, wasn't that week off great?
Yeah.
Okay, who said that? I got to write this down. Who said that? I thought it was wonderful. So we're back. We got a bunch of stuff tonight. The first thing I want to do is go through the homework assignment, which is the readings in the book. Then we're going to look at the Simpson Strong Tie catalog. I downloaded a version today. We're going to go through it. It's a really great resource for all kinds of things, not just knowing what screw to use for what piece of hardware. So we'll look at that. And then we're going to look at some videos from Simpson. You know, here's a case where a company has a monopoly on its business. Nobody competes. There's a few other companies that make framing hardware, but Simpson's pretty much got the lock on it. And, you know, it's not good in that it stifles competition, but it is good in that they mass a lot of money, and out of their guilt, they do a lot of extra things that help building. So we benefit from that as well. They have, and we'll talk about the stuff they have, the services they have, and they're getting more glitzy and helpful all the time. So we'll look at a few. All the videos are going to be short, but we'll look at a few on those. Then we'll maybe take a break. And then I've got some framing videos because we're not teaching framing systematically. You do that in 110 and a little bit in 111. But we want to make sure that those of you who haven't had those classes or haven't done any framing in your life get a little bit of an overview. So we'll continue with the overview. So it won't be a lot. So you have to pay attention and stay awake for that. And then we'll go home. So your books. So again, if you have this from an early email I sent you, it's the syllabus. It's a non-Canvas version of the schedule on the syllabus, and it's got all the page numbers and stuff on it. So it's really handy for both editions of the text you're using. So it's real handy to use that. You know, sometimes you're reading your text and you're not at your computer, so you don't want to go and go look at Canvas and get all that information. I mean, you can just take this with your book and go sit on the beach or wherever you go to study and get the information off of there. And I'm going to use this tonight. So we're on week 4, September 14th. Floor framing review, wall framing review, and then we'll look at framing hardware. So these are kind of, so what we're going to look at in the book, as you probably guessed if you did the homework, if you actually looked at it already, is some summaries of framing, like it'll be pictures of a typical wall, and we'll just go over that real quick, but also some little tips or things to know that aren't as generally known that might help you out. That's what we're kind of doing in this class. We're covering stuff that wasn't covered in the general 110 class. So on your 11th edition, go to page 225, and on your 12th edition, go to 234.
Hey, Patrick, how are you?
Hey, Aurelio, is that you?
Yeah.
All right, guy. Good to hear from you.
Yeah, I haven't seen you in a while. Where you been?
Yeah, I know. 2 weeks is too long to go without.
I know, it seems like I dropped the class. I don't know.
You're a lovable old teacher, you know?
Yeah, you're the favorite one for sure.
Okay, so John, can you hear me?
Yeah.
John Tapia?
Oh. Every time
James,
I'm
can
the
you hear me?
second John. What is this?
John
I
T.
can still hear you, yeah.
Okay. Colby,
what
can
were
you hear
those-
me?
What were those numbers?
Yeah, I can hear you.
Donna, can you hear me? Donna? Okay.
Yeah, I can
Okay,
hear you.
Yeah, you need to unmute so I can talk to you when I need to. And everybody else, make sure you're on the video. Okay. So the great thing about this class is even though I want you to read in between the pictures, especially if you haven't done any framing or you haven't had 110 or 111 yet, but we're mostly going to talk about the pictures, so that makes it easier to deal with things. So figure 8-1 and 10-1, depending on what edition you have, it's just the junction of two outside walls. But it's just 225 in 11th edition and 234 in 12th edition.
Thank you.
So you see the floor system, the concrete is probably a stem wall because you, like we said last week, you usually don't put joist floor systems on a slab. They did that in that little animation, which is crazy. It's just a waste of time and you don't do that. So we can assume that that's a stem wall underneath that anchor plate. So there's a mud sill, they call it. Different parts of the country, different generations call some of these things different names. I always call that sill plate a mud sill. But anyway, that goes on the stem wall. We'll look at a picture, a cross section in a second. Then you have the floor system, just shows the header joist and the end joist because you can't see into the floor. Then it has, you can see the plywood, the wavy lines of the sheathing underneath the walls. And then you build the walls right on that. So that's kind of the, out here we do that, or we have a slab where you put the walls right on the slab. So those are the two common kinds. So you see those diagonal bracing, that's not used very much anymore because it is some places, but there's so many seismic zones in the United States and actually around the world. It's pretty rare when you don't live near a seismic zone. But let's face it, California is pretty seismically active. And we require sheathing now to make to make a whole wall of shear strength. And so since you're sheathing the wall, you don't need to diagonally brace anymore. But when you deconstruct houses or demolish them, you'll see that it's quite common. Used to be wood 1x2 that was actually laid into the studs, and then they started using thin, like 3/16 thick by 2 metal braces that just went on the outside. So, and then there's a little picture down below there, or a cross on the new one of a platform, a still, and then cinder block wall below that. Okay. So moving along, let's see.
Hey, Patrick,
Yes, sir.
have you ever done one of those floors where the floor joists are hung off of the mud sill? They use those strap anchors that go up on top of the mud sill, and then they hang down in front and use a spacer to keep it away from the cement.
No, I've never done that. I've seen it before.
My dad used to do those in Lake County. I always thought it was the oddest thing.
Yeah, I'm not sure what the advantage is, unless you really have a height problem. You can't go high enough, and that'll put the floor into the crawl space rather than above it.
These were all really cheap homes, like out in the boonies. So I don't know if there were some price savings. I don't think there were height requirements out there. I don't know.
Well, you would, if you had a normal stem wall, you'd have less of a crawl space, right? Which is a bitch anyway when it's full size. Of course, now they have a minimum crawl space, so that might not even qualify. But then also, you have to pay for all the hangers.
Yeah.
So that's an extra cost, and that's going to be more probably than the wood rim. I don't know. That's interesting, though.
Here we go.
Okay, so then go to page 245 in the 12th edition.
Oh, yeah, that helps. Well, thanks for that.
Which is 235 in the 11th edition. So see that picture 820 and 1021?
Yeah.
So it's showing a sill plate that's going to go on a stem wall. Yeah.
Mhm.
So we got a little clip we're going to look at eventually, but have all of you done this before, or some of you not done this?
No.
No.
Okay, so here's the trick to this. I'll tell you this. If you're taking 110, Jim will tell you this too. There's a little picture, sub-picture. It's got this V-shaped bracket. You see that?
Yeah.
That's a anchor strap, they call them. You may see them on the Stimson. When you look at the Stimson guide, we're going to quickly go through what they have. And that's kind of a new thing, but I don't see many people using them. You know, I'm not sure what the advantage is. The old anchor bolt, it still seems to be like a pretty simple way to attach the sill to the stem wall. But anyway, so you've got these anchor bolts in the middle of the stem wall, right? Every less than 6 feet, less than a foot from the end. And you've got to drill holes in the sill plate and put it down onto it, right? That's going to be, and then you're going to build your floor on top of that. So that piece has to be treated. Here it looks like it's not, it should be green, but you don't know where the color thing is in these books. But getting the hole in the right place is really critical. Now in the old days, before probably your parents were born, I hate to say it, some of you, but we used to make say we had a 1/2 inch bolt, we used to make the hole 3/4 of an inch. And then it would always fit. There was no way it wouldn't fit. But after a couple of earthquakes in Southern Cal, the engineers said, it's just pulling right through that hole. That hole's too big. The earthquake's pulling the frickin' floor sill plate right off. So you've got to make it within a 1/16 bigger than the thing. So now from 3/4 to, what's that, 10 5/8? No, not even that. What's a 1/16 more than 3/4?
It's 5/8.
13 16,
It's
yeah,
5/8.
almost 5/8.
It's 5/8 anchor bolt.
Oh, it's a 5/8 anchor bolt. That's gotten bigger too. So it's 5/8 plus 1/16. So thanks, Donna. So it's
The minimum, the minimum
11/16.
in building code. The minimum
Huh?
in building code is still 1/2 inch, but 5/8 is what is commonly used.
yeah. In Santa Barbara, 5/8 coming. So you need to drill the hole at 11/16. So that means you got to be more accurate when you drill, or you're going to be fighting this thing. So the important thing about the sill plate is this: it needs to be the outside edge of the sill plate, if you're lining it up with the stem wall and the building line. And it depends on, we talked about that before, where the layers over that, which includes the sheathing and the siding or stucco, how they interface, how they line up with the stem wall. What's common here is to put the plate at the very edge of the stem wall, let the sheathing go down over that joint, keep the wind out, and then let the siding go over that. That's what I've always done, and it's pretty common here. So in order to get that sill plate right on that, even with that outside of that concrete stem wall, That's what you've got to do. It has to be right on there. Now, that concrete stem wall may not be real straight because you may have gotten a crappy concrete company and they don't know how to do a good job, or the form boards may not be real straight. Now, boards often have a bend to them, right? They're not always straight. So if you're joining two boards that aren't straight, where that joint is, that's not going to be straight. They're going to cup in a little tiny bit. So what you have to do is this. You have to take 2.5 inches, whatever your sill plate is. 3.5 or 5.5. Measure from each end of the particular foundation wall you're doing. Go in, make a mark at, let's say it's a 2x4 wall, make a mark at 3.5. Then you're going to snap a line, and you're going to measure from that line to the point to where you're going to make your hole, and that'll assure you're straight. It may not follow the concrete exactly because the concrete may not be a straight line, but at least you've got a house line that connects one end of the footing to the other. So that's what this drawing is trying to show you. So you put the board in place and you take your square. This is where a combination square, the kind that moves. All you young guys just want to use the little speed square, the triangular. But the problem with the speed square is that if you need to have it go less depth than the edge of the square, which is what, 5 inches or so, you can't do it. With a combination square, you can pull it back and, get it to any length. So you're going to take it and you're going to put the square over the board, the edge of it to the center of that bolt, and you're going to mark that because that's where the center of your drill is going to go. Y'all see that?
Yeah.
You're going to measure from the front, from the line to get the distance this way. But to get the distance laterally, you've got to, come right off each bolt. And the reason you have to do that carefully is because the bolts, if we're going to look at a Simpson, those blue and red bolt holders, you've seen those, some of you? Some of you do concrete. Those are great because they're standard and they hold the bolt in a certain place. But a lot of people still don't use those. A lot of people will take 1x2, drill a hole in it, and put it over the, nail it to the top of the form boards, put their bolt in that. That's not going to be as accurate. So there could be mistakes where it's 1/8 or 1/4 off either way. So your bolts, when you do it that way, may not be in a total straight line. So that there's a trick to getting the bolt holes in the places where that board can be put on. And you have to measure it and drill holes where it says. And if your board is slightly warped sideways, that's too bad. You're going to have to bend it. You have to bend it so it'll go into those places. If it's too rigid, too much of a bow and too bent, you have to get another board. So that's all I'm going to say about that. So we saw in that film the other day, the guy had a stick, that framer, and he put it over, it was a steel pole rather, and he put it over each anchor bolt and he straightened it up so it's vertical. Yeah. So before you measure, you've got to make sure all the bolts are vertical, because if they're at an angle and you measure the top of it, it's not going to be where the bottom of it is. So that is absolutely critical that the bolts are also vertical. Okay. So let's go to on the new edition, it's page 247, figure 1022. And on the old, well, you guys are making me work for my pay. 236 on the old edition, figure 821. So you guys that have done some framing, some form work, you either know everything I've been saying or you understand it pretty easily because you've been in the trenches doing it. But how about the people that are new to this? Is this confusing or are you getting it?
Confusing.
Okay, so what's confusing about it? Like finding and drilling the place for the anchor bolts.
I was a little confused by that last diagram. Basically, the directions for using the anchor bolts, I guess I just couldn't visualize direction number 4, measure the distance from the center of the bolt to the outside of the foundation. If the sheathing or brick veneer is to be flush with the foundation, subtract the thickness of the
Okay.
sheathing. or the
Okay.
brick veneer.
Okay, great. Let me just go over that real quick. So go back to that page that it was. If the foundation was perfectly straight on that outside edge, the stem wall, right? If that was a exact straight line, then you could measure, like the book says, you could measure that X distance. See in the figure? It's from the outside to the center of the bolt. And then you just measure that from the board and put your mark for the center of the hole right there. But what if that outside concrete is not straight? What if it weaves in and out a little bit? Then when you measure that line, it's not going to be real accurate, right?
Yeah, I guess what I'm confused by is like if you were compensating for sheathing or being flush with the end of the foundation. I guess what my question is like, wouldn't you be pulling back the sill, and would it potentially like go over the other edge of the foundation?
Okay, go to 227 on the old book. And um, 236 in the new book. So there's a cross section, right?
Mm-hmm.
So, I mean, you guys who frame now, who frame walls on floors, you chime in here, okay? I mean, there's not one, I don't think really best method for doing this. It's kind of the way people get used to doing it. So none of these pictures describes the way I'm used to doing it. So if the B comes closest because it has the sill plate lined up with the outside of the stem wall, but then the floor, I would do the floor system that way too, line it up, but I wouldn't put the wall 3/4 in from the outside of the floor system to allow for that sheathing. Now, some people do that. That's the worst case because then there's nothing that stops wind that can come in the joint of the wall to the floor.
I think in California, Patrick,
Yeah.
our sheathing has to be nailed into the bottom plate, and so we wouldn't be able to inset it. I'm understanding correctly.
Yeah, for your
You mean-
uplift load, like for
You
your
mean-
uplift
you-
calculations.
You mean into the mud sill?
Yeah, it has to be attached to it, like Donna was saying, it has to be attached for uplift loads. Otherwise, we don't transfer our shear loads through the whole structure.
Right.
Yeah,
Okay, so
plus
none
it
of these.
can't sit on the
Oh yeah, so drawing A would do that, right?
Yeah.
So drawing A would be allowable. B and C wouldn't be allowable. But in A, you still have an option in A of going out so that sheathing is outside the concrete, laps onto the concrete, and the mud sill and the floor and the wall are all pushed out where it was, right? So you're still nailing the sheathing into the mud sill, but it's also going down below that, covering the joint on the concrete. You see that?
Yeah.
Now, the reason that's a better way, in my feeling, is because you're covering that joint to the mud sill. Now, we got a film by your friend about different kinds of sill seal, and he's saying that traditional kind's not that great, and I agree 1,000%. But wind comes through that, and even though it's a crawl space, I mean, it could be a basement, but here it's usually a crawl space. If you allow wind in that crawl space, that still can come up into your floor if your floor is not sealed. So you don't want air getting through there. So if you put the sheathing over that space, then it's not so critical what kind of sill seal between the mud sill and the concrete. So anyway, who was asking about the overlap?
I was Patrick, Alec.
Oh, Alec, okay.
Yeah.
So if you do it the way I like to do it, the building line, which is the edge of the outside framing of the wall, and the outside floor of the floor system line up with the concrete. That's not like A. It's A if you pushed everything out and then had that sheathing go down. So in that case, you'd be measuring 3.5 from the outside of that wall on each end, right?
Yeah.
So if it came in 3/4, you know, if you had the sheathing, if you wanted to set the sheathing on the concrete, then you could come in 3/4 or whatever your sheathing was and snap a line the whole length of the wall 3/4 in, and then you'd measure from that line to the center of your bolt. So you could do it that way. But if your sill plate goes all the way out, you can't do it because you don't have a line. You can't snap a line on the outside edge because it may not go all the way. It may not be over concrete in places. So you've got to come back and have a wall and have a line somewhere else that you can put your mud sill on. That's what I was saying.
Cool. Thanks.
Yeah, that's pretty sophisticated for some of you because you're just starting, but don't worry about it. But it's a great question for someone who's going to be doing this, you know. Okay, so go to 236 old edition. And 246 new edition. You see that corner? The sill plate on a corner, everybody?
Mhm.
Okay, so I'm going to use this picture as an illustration of why you need to, we're going to talk a little bit about layout tonight too, why you need to have a short 15 1/4 bay for your first stud layout and then 16 on center for the rest of it. Because if I describe it, no one's going to get it who doesn't already know it. So let's look at a picture. So on that right-hand plate that's going diagonally up to the left, there's going to be a stud on the end of that. That's what that dotted line is, right?
Yeah.
Then you want the center of that next stud at 16, which is what it shows, right? But
Yeah.
you don't put a layout line in the center of a stud. Why not? In the center of where a stud's going to go. Donna, why do you think?
Because there might be deficiencies in the lumber, like it may not be straight.
Well, that could be. But when you're marking a stud, if you mark the center of a stud, how are you going to know when the center of the stud's on that mark? Because you're covering the mark with your stud, right? So even though we talk about a layout on center dimension, 16 on center, 24 on center, it does mean center to center, but we can't lay out the centers. We don't do that. But if you look at 16 on center as center to center, you'll also realize it's left hand of stud to left hand of stud, or right hand of stud to right hand of stud. That's what you've got to realize, that center layout dimension is for all three of those cases. And you're going to use the left hand to lay out, because you're going to put a line on one side of your stud. And usually it's on the side closest to you to begin. So it'd be the left side if you're laying it out, facing the other way. So see where that 16 goes to the center? Well, you can't mark that line because the stud will cover it. So you've got to come back 3/4 and put your first line there. So 3/4 back from 16 is 15 1/4, right?
Can you draw this on the
Yes.
board?
Yes. Got this board right here.
It's
So here's your corner stud. And we want these studs to be 16 on center.
and now, and we're looking at a wall.
This is looking down.
We moved from
This
floor
is-
joist system to wall.
Yeah, this is looking down, but it applies to floor systems also.
So we're looking at a floor system then.
No, this is looking down at a wall, because the wall is
Okay.
easier to talk about, but I'll show you how it applies. So this is a plan view, looking down at a section of a wall. Whenever you see an X on a framing drawing, that's an end section. So that's the end section of the studs. So the studs are 16 on center, right? But if the studs are 16 on center, your plywood needs to go to the end, okay? And that's really important, because if it goes halfway, your nailing's only going to be at 3/4. You're going to have 3/4 worth of stud to nail, and that nailing on that stud for plywood is really important for shear strength. And that's why you have shear panels on the corners. But just without a shear panel, you've got to have really good nailing on that end, because that's keeping your building going this way. So the code says the sheathing should go all the way to the outside of the building. But if you do that, 16's here, you won't have enough sheathing. A 4-foot sheathing won't make it. It would have to be 4 foot if you're doing them vertically, or 8 foot if you're doing them horizontally, either way. It would have to be 8 foot 3/4 or 4 foot 3/4 wide, and sheathing doesn't come that way. It only comes in 4 foot widths and 8 foot lengths. So in order to get the sheathing to break in the center of a stud down here and to come across and go all the way to the end, since you can't add 3/4 to the plywood, you've got to lessen this first space 3/4. So the distance from the outside to the left will be 15 1/4 instead of 16. It'll be 16 to the center, but if I put a mark there and then I put my stud over that, I don't know where the mark is anymore. I have no idea. The marks have to be on either the right or the left side of the stud so you can see them. So you usually lay out, you hook your tape on the end of the wall here, and you go this way, and you go to the 15 1/4, and then you make your left-hand mark. That's where your stud's going to go, 15 1/4 from the end of this plate. Then from then on out, it's 16 left side to left side to the rest of the building. You see that? I've had students come in and say, years ago, and say, my boss just has the sheathing stop in the middle of that stud. Then you don't have to worry about it. You can just do everything 16 on center and not have the first one short. But the inspectors don't like that. Now that we realize we're in seismic trouble here, that end stud has to have better nailing than that. So we're back to 15 1/4 which is 16 minus the 3/4 of half of the stud. Or if it's 24 on center, then it'd be 23 1/4. Does everybody see that?
Yeah.
Yeah.
Yeah, it makes sense.
So we'll look at a guy laying out in a video, just a short video later on. And there's different ways carpenters do this. In the old days, in the 70s, that's before, like I said, some of your parents were born. We used to put a nail in at 3/4, and we'd hook our little 8-penny, because we nailed by hand back then a lot of the time. We put an 8-penny in at 3/4, we'd hook our tape to that, then we'd just go 16 on center all the way out and not worry about it. This guy in today's film, the way he does it is he puts on the end, and then he goes to 16, and then he comes back 3/4. Goes to 32, goes back 3/4. Goes to 48, goes back 3/4. So he just gets in the habit of going, because the 16 centers are marked special on your tape, but you have to go back 3/4 to allow for that, that original short bay. Now, if you look at that drawing again, there's a wall. The outside wall is a long one, the one we've been talking about, because it goes all the way to the end of the wall, right? So you call that a long wall, or I call it a long wall. The one that's butting up to it, you call a short wall, because it doesn't go all the way. It's cut off by the adjacent wall. Y'all see that? Joe? Okay, it's time for a Walking Dead shake-up here. Okay, everybody, wake back up.
Yes.
Look at the drawing. Hey, this is construction. If you don't like it, don't take the class, okay? But try to pay attention. I know you've been working all day and you're tired, so I'm going to remind you, but just try to hang in there.
Are you talking about the are you talking about the drawing that you sent in the first email?
No, I'm talking about the drawing on 236, old edition,
Okay.
246 new edition. Joe, do you have your book?
Yes, sir, I do.
Okay. Okay, I hope everybody's got their book.
Yeah.
I know sometimes you can leave, well, it used to be people left them at home when they went to school, but you can't use that excuse now.
No, I have everything. I'm listening. I just have a hard time like on computers because I'm not very computer savvy. So I was looking for the unmute button, but I was listening to everything that you were saying.
Okay, but can you see me?
I can see you. Can you see me?
Yeah, I could. Yeah. Okay.
Right.
So that other wall in the picture is butting against the first wall, right?
Hold on a second.
So it doesn't go all the way to the end of the foundation. It's 3.5, if that's how thick that wall is, wide that wall is. It's going to be 3.5 short, right? Everybody see that?
Yes.
Yes.
Aurelia, was that you?
Yes.
God. So what is that going to do to our layout? It's going to screw it up, right? So when you're building that second wall, the short wall, on the platform, and you're trying to put your tape on one end of it to lay it out, you can't do that. Or at least you have to do something special. What do you have to do?
Pull your layout from the edge of the first wall.
Yeah, you could put the board in place. Yeah, good point. You could put the board in place and just string across it. I never thought about that. Or if you're doing it away from there, you can just scratch 3.5 inches, right? We used to scratch 3.5 inches. Then we put a nail in there and then tape from there 15 1/4 and 16 on center. But it's going to throw the layout off because you have an additional 3.5 inches it has to go to. Now, a lot of people don't care about that. And what if you just make your short wall 15 1/4 or 16 from one end, what's going to happen is a 8-foot piece of sheathing is not going to fit. You're going to have to cut some off and waste some. But it's not a lot of waste. and it may be easier than trying to train your crew to know how to do the math. So there's all kinds of things people do, companies do. Anyway, to do it really the best way is to do, have everything have the sheathing go all the way to the end and then break on a stud. That's the goal you're trying to make. All right. Okay, so on the new 258 on the new edition, which would be, oh, I don't know. 248 on the old edition. Hey, Donna, did you get this?
Yeah,
Hello?
I understand.
Okay. Yeah, let me know if you ask about something and then I explain it to you, not just you, Donna, but all of you. And I'll either explain it again or say, figure it out for yourself or on your own, or talk to me privately, because I don't want to waste too much time. It looks like everybody got that. Okay, so these pictures on 258 and 248, it's just sheathing. Some of you have sheathed floors before, but many of you haven't. So again, this will be something Jim, who has Jim's 110 class now? Jim Cunningham.
I do.
Oh,
I
John,
do.
okay. Okay, James, what stage are you guys in? Oh, I mean, what are you talking about?
Chapter 5 right now.
What's that?
Chapter 5 right now. All right, we're on chapter 6. This next week coming up.
What's that? Have you done any framing? Has he talked about any framing or foundations?
We were just talking about power tools recently.
Oh, okay. Yeah, I don't know what his pace is. So actually this will help you do that. And if he teaches a certain concept, this will help you with that. So. What was the new edition, 258? Yeah.
The sheathing, yeah.
Okay, so just a few things to remember about sheathing. So I went to school the other day to get to move some boards around, and I moved some of the Fiesta platform that I used to build and may still build. We store a lot of boards there, extra boards, and I'm 73, and I probably shouldn't have been lifting this piece of plywood by myself. It was heavy, and I got a bunch of them inside, and then a week later, my back just killed me. So when you're working for a crew and they're trying to make money, they're going to want you to be able to throw around sheathing boards by yourself. If you have an enlightened crew leader, company director, they'll know that that's not very ergonomic and it's really hard on your body. And a lot of carpenters wear themselves out by doing that for years after years. So see if you can get, if it's okay in your company to have 2 people lift a 3/4 inch board or bigger around. And if he says, fuck no, do the work, then you can do it and, wear a back brace or, build your back up a little bit, but it takes its toll. So that's one thing. See, Donna, the floor on that is just like the wall. The sheathing's got to could come all the way to the end of that joist, and then it's got to break on another joist. So that first joist is going to be 15 1/4 away from the end joist. So you're going to stagger sheathing, right? It's going to be 4x8 boards of occasionally they're still using 3/4, but they're going into bigger boards now, 1 1/8 and stuff. So they're going to be staggered and different. I don't know what the code says. in terms of spacing. Everybody's got their different thing. There definitely has to be spacing between the ends. See where it says eighth inch spacing? We used to just put a couple 8-penny nails in there, and do the next one, because that's where your board's going to expand and contract. And then they sometimes require an eighth the other way, laterally along the edge, but sometimes you have tongue and groove boards and you can't do it, they don't work that way. They just go into the slot. So that's less, I don't know, anybody know the code on the edge, the long edge of ply, of sheathing?
10 inches?
No, I don't mean the pattern, but how much space you have to leave between each row. See, on the book it says 1/8 inch.
Yeah. Well, when I've been on the past couple of job sites that I've been in on race foundations, I always get some nails. They always keep them with them in their bag, and I'd have to go in there and pick them up with a magnet, but they just get a nail, I think 18D or something like that, and they just leave them in between pieces of plywood, and they just butt them up. They just kind of went off of that, and the civil engineer would just come by and check off. He'd just stamp things off. He's like, yeah, it looks good. It was Gordon Fiano. They always do a solid job.
So did they Gordon Fiano?
Gordon Fiano was doing the roofing. Yeah.
Okay. I worked for them once. So they space it both ways, and on the ends and then on the sides too?
Yeah, I'm pretty sure.
Okay. This is a dry climate, and it doesn't get, once your house is sealed, it doesn't get rain, hopefully, and it's not very humid. So a lot of things that apply to humid climates, like a place where it really has a lot of humidity and there's really differences, you really want those spaces. But I've done a lot of floors in Southern California for 40 or 50 years, and sometimes we didn't do the sideways things. Like I said, sometimes they're tongue and groove, and I've never had a floor come up. So that's why I'm saying, I don't know how important it is. However, if the code tells you that's what they want, then that's what you have to do.
Hey, Patrick, I'm a little confused because the code either calls for TNG or blocks under every joint, right? On the long side, how do you space the long side of a TNG?
Well, that's what I was just saying. You can't.
Yeah.
So, so that's why I'm not sure how.
The spacing is theoretically engineered into it or something. It has some sort of
Right. Well, if it's if it expands and contracts, it's gonna, if you've got the tongues really tight into the groove, that's the same as there being no space. So, whoever's got Jim, John Tapia, you have Jim, right?
Yeah.
Okay, whoever else has him, ask him if he knows if there's a code for that or what people are doing now in terms of the edge of the sides of the board, not the ends. The ends we know has to be 1/8 of an inch. Okay?
Okay.
And report back next week. All right, then there's a nailing pattern which changes over the years, but it's probably still 6 along the edge and 10 in the field. So not every board has an edge, right? Only the ones that are on the edge. The next row doesn't have an edge, so all the nailing is going to be 10 inches along the joist. Yeah? All right. It's obvious you've all mastered that before, so. Okay, so go to 264, new edition, and 254, old edition. Okay, this is a pretty good picture of a wall, typical wall, but I want to show you some variations, some differences. Everybody there?
Yeah.
Yep.
So forget the corner. The old corners were a 2x4 with blocks, two 2x4s with blocks in between. I'm going to try to talk you out of that when we talk about advanced framing later in the class. Jim still likes those corners because Jim started framing when I started framing. And that was the way we did it for 20, 30 years. And it's very solid construction. And it allows for a little bit of, it comes out past the wall so you can nail your, it has a sheetrock nailer as part of it. But it's crappy for insulation, really crappy for insulation. So forget that part, but the windows, so look at that first window. So for those of you who haven't framed a wall before, look at the names of the parts. So you've got studs, right? That's the bulk of the, and studs are the whole length from bottom plate to top plate. If the studs are broken for a window or a door, remember we said that the weight is spaced 16 or 24 on center, depending on the width of the wall, to bring down the weight of the floor above it or the roof. So if you break that pattern, you've got to transfer that weight. And the only thing that'll transfer it is a giant piece of wood that'll take those forces and move them sideways to come down on the nearest piece that can come down. So that's why you have headers for doors and windows, because you have to transfer that weight. On a side that's load bearing, when we get into advanced framing, they're starting not to do that on the sides. Like say you have a gable roof on the sides, the gable end, where there's no weight, the roof comes down on the other two sides. And they're using very minimal headers. But for now, so you've got a header, and then you've got to have the studs that would have been there below the window and above it, because you've got to transfer the weight to the header from the top plate. So you've got to have something in there. And then underneath, you don't have any weight you're transferring for the bottom cripples. But those are just there for what? If they're not there because of the weight, what are they there for?
Nailing.
Nailing, yes, exactly. So they're on layout because you've got to nail sheetrock and sheathing and siding to it. So they don't have anything to do with the weight because the weight's already been transferred by that header to the side trimmers straight down to the ground. It doesn't go back into the inside. Or maybe a little does, but it's negligible. Now, there's a difference in framing regionally. So I worked in Maine for 10 years, New England, and they do it differently than this. And I think when I was in California before that, in the 70s, we used to do it this way too. So you framers, tell me how you do it. So we used to put a king stud, and then we'd nail the header into the king stud on the edge of the window or door. Now let's say window, we're talking about window. Then we'd take the sill and we'd run the sill into the king stud. We didn't run the trimmer all the way down to the ground. We cut the trimmer in two. We put part of the trimmer between the sill and the header, and then we put another cripple stud at the end of that lower framing below the sill. They're both the same way. You're still transferring the weight. So yeah, here, let me draw it. Is that what somebody asked? Donna,
Yeah.
is that you?
Yeah,
I'm glad you asked for pictures. That's great.
Yeah.
Yeah. Okay.
You start throwing around numbers, and I'm like,
Okay.
I kind of think that having the bottom so loose like this would lead to more movement, more cracking and sheetrock.
I agree. People slam windows all the time, and
What's
you
that got
know,
to do with it?
over
Well,
time.
it's not locked in between the two pieces like how they used to do it.
I agree.
Okay, so here's the header, and here's the sill, right?
hmm
So we used to do it this way, because we could back nail the sill and the header, of course, and then we put a trimmer in between these two, and we put a cripple on the end. So this is still one continuous, and then a cripple up there. It's still one continuous load bearing, but you can back nail the sill, which is really much stronger than toe nailing. And if you have a trimmer in the way, you can't get through that with an 16 penny nail. So it's a weaker joint right there. Plus, it's actually easier to do in many ways.
Now you're talking about now. It's a weaker connection, right?
Well,
Not
yeah,
like-
I'm saying it's stronger if you can back nail always. Toenail's not near as strong. So the way they do it now and the book showing is you have a king stud here and then you have your trimmer go from the header all the way to the ground. Then you run your sill to that. But you can't back nail because now you've got to go through 3 inches and a 3-inch nail won't obviously be long enough. So you have to toenail this, however you want to do it. But also then you're going to put, what they do is they don't always put, they put the cripple jacks on layout. So they may not put one on the end there. So then you don't have this sill resting on, at the end, resting on a cripple like you do on this side.
You have to.
Huh? So that's another thing that you gain is you don't use any more wood, but you gain something that's actual piece of wood that's holding that header. So I think it's better. I don't know that our local code says you can't do it, says you can, I think it says you can do both ways, but just know that there's some variation there. On the right of that window in the picture, they do put a cripple, and then you've got three pieces of 2x4 in a row. That's 4.5 inches, 4 3/4 inches. So you're losing insulation in there. And when we go to advanced framing, the whole idea is to use less wood and more insulation. That would be a total no-no. So we'll talk about that later. With a door, it's the same because there's no sill. So your trimmer, if you look at the door, your trimmers go all the way to the ground. That's pretty straightforward. Sometimes in those headers, if your window's high, goes closer to the ceiling, they can eliminate the cripple studs and just use a solid header all the way up in there. You've probably seen that. Then there's further down the wall, there's a looks like a corner. Well, it's a, what do you call it? John, what do you call that? Where an intersecting wall hits.
There's a backer. What
What do they call that whole section?
you talking about the neck one stud bay over from the window?
No, to the right of the door, there's that where it says framing for intersecting partition.
Are you in the new or the old book?
Both books.
Oh, you mean the upper one?
Yeah.
It's sheetrock backing.
Yeah. Well, the thing you nail the wall, the partition to.
Sheetrock nailers, sheetrock backing, whatever you, instead of your favorite sheetrock clips.
No, yeah, I'll get it. I'll find it. I just forgot it, what it was, but we'll talk about that later because it won't make sense until we talk about advanced framing. So if you guys are new to framing, that's pretty much the standard layout for a wall, okay? And those are the standard terms. We tend to say cripple studs in California. Back east, they use jack more. A jack is a short version of something, jack rafter, a jack stud. So jack's a term, when you see jack, it means curtailed or shortened in some way. Sometimes they even call trimmers jacks. Have you ever heard that?
Yeah.
And trimmers are a shortened stud, so it follows that. But trimmer is a much better word because it's specific. Anytime you have a variety of words, choose the one that only is for that situation. The jack could be for several things on that wall. So, yeah, John?
In Northern California, where I was trained, that what they're calling trimmers in here, that was the only thing they call a jack stud on the inside of the door frame. That was
Yeah.
called jack.
And then they call the cripple studs.
Yep.
Yeah, okay. So yeah, so that's gonna vary regionally a little bit. All right. We're getting through it. Okay, go to 270, 12th edition. And 260, 11th edition. Is everybody there?
Yeah.
Yeah.
So they're showing a layout, and look at the step 2 or figure B of 911 and 1111. The bottom one, figure B in that figure. So see that some of the studs are marked C. That's for cripple, right? And T's for trimmer. We used to put a K next to T because that's the king stud. It's a regular full-length stud, but it's the one that goes next to the trimmer, so it has a specific function. So sometimes you'll see that as K rather than another X. They put an X because it's a full-length stud, so that varies too. But so the one thing I want to say about this is when you're laying out a wall and it's got windows and doors in it, lay out the windows and doors first. Can anybody guess why? You get an A in the class if you answer this correctly.
So you know the span of your wall.
Okay, I take that back. What?
Well, listen. Give me a chance.
Okay.
If you do.
No,
your
I don't want to give you an A
windows
just for that.
Well, I'm not trying to kiss your ass.
I-
I'm just saying it for what
Go
it
ahead.
is.
Go
My
ahead.
experience is that when you get all the cutting and all the detail shit out of the way,
Yeah,
then it's easy to put up a normal stud or a trimmer. You know, you want to get the hard shit out first. Would just common sense talks to me and says that. You know, it would
Okay,
make sense to just do something like that. I
okay,
don't know.
that's not the answer I'm looking for. It's certainly true. That's true. Yeah, I mean,
Is it
you're right.
that the headers are at the same height as the door, the top of the door? For the windows, the headers?
Yeah. Oh, are you answering that?
Yeah.
What was it?
The window headers are the same height as the door?
Oh, no, so we're not dealing with height because we're just laying out the plate. So we're dealing with where the studs are going across the wall, not the height of anything yet.
Oh, there you go. He's right there. So if you frame that out, you know where to put in your studs every 16 inches, right?
Yeah, so if you lay it out by studs every 16
It's gonna
inches,
be all fucked.
you're not gonna, it'll be right, but you're not gonna know which ones are cripples. So when you go to frame the wall, you're gonna go, oh shit, which one of these X's is a cripple stud and which one's a... So what people do is they'll lay out the wall first and then they'll go back and cross out the X and put a C.
Shit.
So time is money, right? So you'll really impress your boss who's trying to cut milliseconds off your work, which is the insanity of the construction profession. But if you do it and you do the C's and the T's first, then you go out and you do the C's on layout, but first you find out where the window is, right? So you've got to measure the floor plans will say the window's, 6'4" to the center of the window. Oh, here's another thing. Windows are laid out by the center line. You'll learn this in the blueprint reading. So the center of the window will be 6 feet from the edge of the wall. So you mark that 6 feet and then you come back, you find out what the rough opening of the window, and that's on the plans too. Say it's
Right.
3 foot, the rough opening, you come back half of that, 1.5 inches. That's gonna be the inside of your trimmer. So the first thing you do is find your window and door center lines, then find the edges of your windows and doors, edge of the rough opening. Then that's where your trimmer goes. So you can mark a T there, and a K next to that for king stud. Then you go back and lay out 16 on center, and when you're inside the window or the door openings, then you put C's instead of X's. You see that? Do you understand that sequence?
Yeah, I mean,
Aurelio, is that what you do?
Yeah. Yeah, you gotta find all your openings, so
Yeah.
then you know where you're gonna have all your stuff.
Yeah, if you do the 16 on center layout first, you're gonna have to cross half of it out because your windows will come in and your doors, and it'll just confuse you. So always mark the windows and the
Yeah.
doors first. Now, I didn't want to talk about this, but I can tell that we should say something. So here's your wall. And say there's another wall out like this, and say the plans show the window as 6 feet from the inside of the wall. Okay? So there'll be a center line. I better make CL. So the concept of rough opening, which you will learn in Jim's class for sure, but that's the opening for the window. And it used to be when windows were more uniform, when I was your age, we could actually just take the nominal size of the window. So it was a 3 foot 2.0 window, 3 foot for the width. We could say, well, the rough opening is going to be 3 foot plus 3/4 on each side, so 3 foot 1.5. That would be our rough opening. But since that time, they've proliferated with a million window types and shapes, and they've totally not standardized the width. You can have a 3 foot window that's under 3 foot wide, or you can have a 3 foot window that's 3 foot 1 inch wide. None of it's standard. So the architects just threw up their hands and said, well, this is bullshit. So they said they have to find the rough opening from the manufacturer. So you're getting a certain, and when you order from a manufacturer, they send you the rough opening. You say, I want a 3020 window, they'll send you back all the necessary dimensions you need. And then you have to put those on the plan. So you'll actually put the rough opening on the plans. It'll be on a little schedule. We'll say rough opening is, let's say in this case, it's going to be 3 feet. That means the window's a little smaller than that, will fit in there. So we go, that's our center line for our window. Then we're going to go back 1.5 feet, right? This isn't drawn to scale. So rough opening is 3 feet, so it's 1.5 inches on either side of the center line. So then this will be the trimmer will go further past that because this is empty space in here. So you find that line from your rough opening, then you go back 1.5 inches. Mark this thing T for trimmer. Go another 1.5 inches, K for king stud. Do the same thing on this side, T, K. Then do your layout. 15.25 here. 16 will be here inside the window or underneath the window. Another 16 will be here, and so on.
Those are cripples that you just.
Yeah, right. And then mark those cripple. Thank you. All those inside that window opening.
we paint them blue.
Yeah, you could actually,
I'm just kidding.
No, no, you can, occasionally you'll see a carpenter use different color crayons for different things, but bosses are going to think that's too fussy or slows you down. So sometimes it's easier just to use the letter for the difference. But it'd be great if you could put the cripples in blue and then the studs in black. Yeah. Anyway.
King studs in red.
Yeah. So, and then we got a yellow crayon for something else. Oh, and green too, huh? Okay, so okay, I think we just got one more thing I want to mention.
Hey Patrick, when are we gonna have a class like at the Wake Center?
Oh God, I'm hoping spring.
I can't take this shit anymore.
You
Can't. It's not cool.
know, this one's hard enough, but the next one's the roof framing. All we do is go out and make the roofs out in the patio. I don't know what that's going to be like. Even if that spring doesn't start at school, it may like go a few weeks and then go to school. There's that possibility too. But the problem is, Santa Barbara's kept, our COVID numbers have been pretty good actually. North County not so good. Lompoc and Santa Maria haven't been as good. Santa Barbara and Goleta have been pretty good. And, if the state would let us, we could probably open up. But the state goes by county, right? And so our numbers are skewed by North County. So if it doesn't come down up there, they're going to say, no, Santa Barbara County has too many infections, so we're not going to let you have in class, face-to-face classes. That's the sad part of that. But the other thing is, let's see, this class is over in
December 7th.
December. So they say, that we may get a virus by October or November, but then it has to be manufactured and distributed, which is a whole nother fiasco. So possibly early in the year, we might have a vaccine, which would really shortcut everything, right? Then we could kind of get back to a little bit more normalcy. Okay, so go to page 280 in the new edition, or it's probably like 270 in the old edition. Yeah. You there?
Kinda.
10-4.
So here's something I want you framers to weigh in on. So when I was framing, I worked for a framing company like Gordon Fiano years, like in the 70s in the West End of LA. And we always put there's two plates on the top of a wall for you new people. And this picture of 1132 in the new edition or 933 in the old edition shows how the top plate locks the walls together. So it, like on a partition, it extends through the top plate of the outside wall. They break that top plate and allow the thing, and then in the corners, it's the same way. So we used to build the double top plate, the top plate's often called the double top plate. We used to put that on the wall. And then when we'd put the new walls in, we'd put it, we'd make sure that the one that went over was the second wall. But we'd put it on before we put the wall up. Some people just put the walls together with a single plate. And then when the walls are up in place, then they go back and put the second plate on and overlap it, right? So you people who have framed recently, what do you do?
Well, it seems like if you knew what you were doing, it's better to just put the second top plate on there and have it all done. That way you don't waste time. You're efficient.
Yes.
You're seasoned and you have tons and tons of experience.
Right. That's a great answer, because you have to know what you're doing. But if you do, you can put that on when it's on the ground. How easy is that? You're just nailing another plate to it. Otherwise, you got to get a ladder. So you got to find the ladder, get in the right position, cut on top. If you're cutting a break in the wall, like on there, you have to use your skill saw on the ladder. So it's a little more dangerous and it's more work and it takes more time. So that's why they used to do it that way. But you have to be good. If you're not comfortable with it, it's probably better to do it the slower way, you know, until you're really fast with it. So when you get to a framing company, if you guys are new, look and see. That's what you'll be doing anyway. You'll be looking and see what the advanced frame, you know, the guys that have been there a while, or how they're doing things, and they'll kind of expect you to do it the way they do it anyway. Okay. God, that was fun. Okay, so here we go to, can you hang on, just do a little bit of Simpson catalog and then we'll take a little break.
Yeah.
Okay, so I need to share my screen. Do this, and that, and do this, and do these, and do this, and share. Okay, so does everybody have a wood construction connectors on their screen?
Mm-hmm.
Yeah.
Okay, super.
Yes.
So you can, when you see how, we're going to go through this catalog, when you see how valuable it is, you're going to want to get it. And Simpson gives it for free. You go to their website, I'll show you in a second. You go to their website and it says download PDF, and you just do that. And then you've got yours at home. Sometimes it's handy to have a hardback version, and you can write to them and they may send you that free too. You know, to take to the job site where you're not going to have a computer or digital pictures. But anyway, let's go through it and I'll show you how valuable it is. So they update it every few years. And they say wood construction connectors because they also do smart walls and strong walls and all kinds of other more advanced complex framing things. But these wood construction connectors are things that all framing carpenters use daily. So it's gotten pretty, so if you want to just find something exactly, you have to know the exact name of it, which is why nobody uses this index. Who the hell would know the names of these things? Although I bet John knows more names than I do. John Sesser's got a good memory. Maybe some of the others do too. So I skip that and I go to subject index. That's for us dummies. So if I want to look up fasteners, so there's two words you need to know. Fasteners, which are the screws and nails that hold the connectors together. So you've got two words, connectors and fasteners. And those are words of the trade, and Simpson Strong-Tie deals with mostly connectors and fasteners. Okay, so we're gonna just blow through some of this. I don't know what the hell that is. The new products, blow through that. More new products, nah. Nah. Some of this information may be interesting. So here's one, corrosion information. So some of this information will be useful for you to find out what kind of fasteners you have to use with what connectors. That's kind of a daily thing if you're hanging joists or putting posts up. But there's also a whole bunch of just information that's good for carpenters to know. So one of the things I want you to do is, for homework, and I'll assign it formally at some point, is to look through this catalog and a little slower than we're going to do tonight. So when they started making pressure treated lumber so that water wouldn't rot it, right, and termites wouldn't eat it up, they would just innocently put various metallic chemicals that were poison to these bugs and they, pressure treated them with these things. Then we started putting metal fasteners through these, like anchor bolts and whatever. And we found out that the chemicals in the board started reacting to the chemicals in the metal fasteners, corroding them to the point where they were unsafe. And then we went, uh-oh. So then what they start doing is trying new chemicals, because our motto is better life through chemistry in America. And sometimes this would work and sometimes it wouldn't. So over the years, we've got kind of a lot of information. This tells you what the state of the art is about corrosion. It's not just treated wood, also different metals together can corrode. So you can't use certain metals together. So that's useful information. This tells about materials that are coated to deal with corrosion, and it tells how strong that coating is. So gray paint is hardly worth anything. Powder coating is better, galvanized is better. Then we've gotten lately a lot of strong, stainless steel is obviously the best, but it's mucho expensive. So we've gotten different kinds of galvanization, and you can look at that and it tells you what the degree of low, medium, or high corrosion resistance. So this is just interesting stuff to know. Let's see. Okay, this page called a conversion chart, really interesting. So if you want to convert imperial, which is what our standard, to metric, this is great. It has inch, feet, pound, bolt diameters. It has those. Sometimes you'll get a system. People are importing prefab units from Denmark, so a lot of their stuff will be in a metric system, and so this is great. This is great for you to have to convert those. Also has roof pitches, which is really great. So we have 512 roofs out here. They're 23 degrees slope, which you don't need to use for making the roof, but helps for solar. This has nail. Oh, this is sheets. I don't know. It probably applies to nail, but there's another table for nails because that's really important now. We'll look at one of the videos for Simpson, and I'll talk about how important the right kind of nail is. So then we'll go into that a little more. Simpson joist hangers, and we'll look at this will be in the movie also, but here's a written summary of those. These joist hangers have different holes in them, different shaped, and they all mean something. So the round holes mean you have to fill all these holes. These are mostly round. These are not required, these always fill to the oblong. They call them ob-rounds, a new word they made up. These are masonry holes. These are max auxiliary nailing. And these are temporary fasteners, they're not necessary. We'll look at dome nailing. There's a little round dome that makes the nail go a certain way. That's really a cool thing. Speed prongs. A lot of these hangers have prongs that you can, while you're setting them in place, you can nail them temporarily with these prongs and then go back and nail. This is a plan view of boards being connected with these dome nailings. The dome nailings force the nails at a 45, so they go in like that. That's a great connection because it's stitched together. So that's good to look at. Now we have fastener types. This is really interesting too, because with nail guns now, nail gun nails are smaller often in diameter than hand nails. And so when it requires a certain thickness, you've got to double check your nail gun nails, make sure they're actually thick enough to do the job. So you're going to have to get used to fractions of an inch. You know, instead of an eighth of an inch, it'll be 0.162 or whatever. A 16D sinker, which used to be the main nailing. Now nail guns use all kinds of other nails. It's like, what's 0.148? 6. That's like a sixth of a. It's like a fat eighth. And then we have these new things, these SD and SDS screws that Simpson Strong Tie makes. Does everybody see these?
Yeah.
Okay, so you can't use sheetrock screws for much, except for screwing down sheathing. But for framing, you can't use those for hardly anything. So Simpson developed a new type of screw that screws instead of bolts. So it used to be a lot of hardware was bolted together, which meant you had to have straight holes through a beam. It was hard to do. So they developed these screws that are made differently than normal screws. They're pulled like nails. They get a long piece of metal and they pull it to the right thickness and then they cut it and do this. So it has a lot more shear strength. So we'll show you in hold downs and stuff where these nails are used now. It's a great innovation that Simpson's had. See here, it says fastener design information. So connector table nail. So if you don't know if you're not familiar with what these fractions, decimal fractions of an inch, you don't know what kind of nail you're talking about. So it's good to start getting aware of what these fractions of, what these thicknesses of nails mean if you're using nail guns, etc. Okay, now here, this is a retrofit thing. If you're retrofitting a house and the sills are rotting and you've got to take them out. They were originally in anchor bolts, but they've rotted. I've seen a lot of this in this area. You've got to put a new plate down, but you can't put, you don't have room. There's a wall above it. Say, you don't have room to put a bolt in. You can't get a drill in there to do it. So you can use these kind of new URFPs are called. And they will screw into the concrete and into the frame, and it'll act as a, see the picture here, it'll act as a substitute connector. So they've got these, they're like hurricane clips for various applications. So there's just one application after another. These are those things we saw, those anchor clips, what do they call them? Mud sill anchors that stick in. They're not as handy as the other types, so I don't know that people are using them much right now. It's got, oh, here we go. So anchor bolt holders. So for a 2x4 wall or a 2x6 wall, it's the blue clip, and you can nail it in several places. One, if it's a 2x4 form board, for the 2x4 wall, it hits, there's that little piece that comes down, it hits right here. You just jam that into the side of the form board, then put two nails or screws in, and that holds your bolt exactly the right distance from the form, which is the edge of the concrete. Yeah? So these things are great. They're much easier to put on. They're more accurate. Also, you can screw them in to the right depth. You just turn the anchor bolt, because you've got to have the right amount of bolt above the concrete. So you need to measure it and find out how much this bolt needs to be screwed up past this junction here. And that'll give you enough room to put one of those big honking square washers and a nut on. So that's really critical, but these things will hold that height. Whereas if you're just putting a piece of 1x4 across your form board, drilling a hole, putting this in, you'll have to do the same thing, measure, but it's a lot more involved. Here, if you have a long anchor bolt, this is for a hold down. They actually have another piece that goes on to stabilize it because it's so long the concrete's going to push it around. So these are hold down bolts. So this is just good stuff to browse through. Hold down bolts and anchor bolts, it shows how they, or just long anchor bolts, it shows how they can be put at side angles. They should be put at side angles to be strong, the strongest force in the concrete. So this is a great place to go for pictures to see how things work, right? So here's, so now these are called bearing plates now instead of washers. And, I don't know what they keep upping the size. Donna or John or anybody that's framing now, do you know what the minimum size of these bearing plates are now?
Inch.
An inch by an inch. So I bet they're bigger than that.
No, the thick.
It's the largest ones to sell at Hayward's. I know that.
Yeah, they're a couple inches at least.
They're almost the same size as a plate, man. Maybe 3/4 smaller, inch smaller. So
Yeah,
at least 2.5.
okay. Okay. So, the earthquakes have forced us to make the bolts hold the plates on the, because if the plates pull off in an earthquake, there goes your house, right? There's nothing, there's
Or
nothing
mudslide.
holding it.
Or a mudslide.
Yeah, there's nothing holding your house together anymore. So they made these so thick that there's so much metal that the earthquake's not going to pull the washers. The earthquake just used to pull the washer right through the board. A 3/4 inch washer, it would just, the force is so strong, it would just carve a 3/4 inch hole, and that would be, your plate in your house would be gone. So they learned that we need really hairy things now. And see, there's a 16th plus for the hole too. So they don't want it very big. They don't want a hole that's bigger than the anchor bolt. So if it's a 5/8 anchor bolt, you need 5/8 plus 16th hole there. So this shows you a picture of a mud sill on a stem wall. It's got to have a minimum 7-inch embedment, but there's only 2 size anchor bolts they sell at Hayward. So the longer ones are usually the ones that you have to use.
They're 3 inches by 3 inches, Patrick, or
Okay.
almost that.
Okay. Yeah, they keep getting bigger. They were 2x2 for a while, and then they're, yeah, I mean, they can't get bigger than 3x3 because it'll be bigger than your plate pretty soon. Let's see, where was it? Oh yeah, here's a picture of a hold down. If some of you are wondering what that's about, it's got the long anchor bolt. It's got a little curly Q on the bottom because it holds concrete better. But instead of holding the plate down like an anchor bolt, it goes all the way up into the floor. Sometimes these are big enough to go into the floor, especially if like on a slab. The bolt itself would be enough to fit onto this because this would be down here. But for a raised thing, you'll have to connect it with these couplers, and then it goes into this hold down plate here. We'll show more of that. So now your house is connected to concrete. The foundation connects your walls. What was happening was it would hold the plates okay, but your floor is just toe nailed to this, and the earthquake would just separate right here. So your plate would be nice and fastened to your concrete, but the rest of your house would be 3 feet over to the side. So now we're connecting, or if it's a slab, same thing. The walls, the studs would just be nailed And those nails are from the bottom. So the earthquake would just pull the studs right up. So now we have these hold downs at critical places, usually just in the corners, but sometimes in the middle of the wall. And that fastens the framing of the walls to the foundation. So that's something we learned from earthquakes. We have to do more than just an anchor bolt. This shows different, if you do 2 stories, multiple stories, sometimes you have to put a threaded rod from that anchor bolt all the way through the first floor, sometimes up multiple floors to connect all of the building to the foundation.
They do that at UCSB.
Yeah. So here's a picture. It tells you, you've got to get this hole in the right place and the anchor bolt in the right place, because you only are allowed so much tilt for that to go back to hit a hold down. So, that's something you need to learn to do. So there's a lot of different kinds of hold downs. Your architect, your plans will specify where and what kind, what size, so you don't have to make this up. Used to be, we made most of it up. The architect would just say, use hangers, use the right size joist hangers, and that's what we did. We'd go buy those. But now, because of litigation and earthquakes and everything's spelled out to the degree. And so you've got to, that's why Simpson's done all this, because you've got to follow the plans exactly. If you don't follow the plans and you use a piece of hardware that wasn't called for, or you use a fastener that wasn't called for, you can be sued. If that earthquake damages the house because these failed, because you didn't use the right fasteners, for instance, your ass is on the line. So it's no longer it's critical now. So I won't go through this whole thing. I just want to give you an idea of, here's something really cool too. They make these software, and I don't know if Simpson gives a lot of stuff away because they know the more you know about how to use stuff, the more you're going to order from them. So they make more money than educating you than they do anything else, than they would selling you. So these software programs may be free. I mean, you can look it up. I looked it up and I didn't see any money partway through. But I mean, it's really got great stuff. Site-built shear wall. Sometimes you don't want to buy a strong wall or shear wall that's made because they cost a lot. And you can make it yourself, and this gives you ideas on how to do it. Fastener finder, which fasteners to go with what. So these are really great. They're programs you can pop in your computer. They're apps. So then the other really interesting group of things, you had anchor, you had foundation anchors. That was like the first part. Then you've got post anchors and post caps. The things that if you want to put a post, like for an outside pergola or something, there's all kinds of bases that have to go in concrete, and then they're screwed to your framing. There's just a whole variety of these for different reasons. Here's one that has a little plate so that this whole thing goes on the concrete, but you don't want your wood to go on the concrete. So, because you don't want the end of that post to get wet. So this one has a little piece that goes in there and keeps you put the post on that little bracket that spaces it from the ground, and then you screw it in the side. Here's a picture of it. So those are very useful. They're not as strong. The hinge is not as strong, so they're only good for smaller applications. But that's the thing you're going to learn too. I mean, look at this. It's unbelievable what's out there, huh? So let's skip down a ways. I just want to show you a few more things. When we go into outside framing, we'll look at more of these things because when we look at decking, you'll be using some of these for decking. And Simpson has a whole booklet on decking, which is free. So, I mean, there's joists that'll put joists or beams at angles, 45 degrees or other angles, sideways or up and down. because everything's got to be connected now. You can't just nail things together anymore. The earthquakes have taken care of that. So and then you have hangers. You have tons of types of hangers that are stronger than others, have finishes that last better, this and that. So, you know, it goes on and on. For use with I-joists, glue lambs. Let's see if we can find an I-joist picture. Oh yeah, here. So you've got these I-joists, and there's several different hangers because they're different than a regular joist, right? If you have two I-joists together, check that out. They make a special, you know, hanger for that. Yes. Okay, so let's see. It's overwhelming, huh? Good thing you don't know all this at once.
Mm.
Okay, so actually I'm going to quit. It's just making everybody dizzy. So as you're learning to frame, you know, go through this. It's free. Download it. Have it on your computer. And it's a teaching tool. You know, we're using a lot more strapping now. And this tells you the kind of strapping and, you know, your blueprints will specify the type of strapping. So you can find by the letters what it's talking about. It also tells you how much you have to nail. You don't always have to fill all the nails in a strap, but you have to do what it says. That's the thing. Here's all your rafters now have to be strapped over the top of the ridge. So straps, that's a whole nother world. You know, Home Depot, all your lumber and hardware stores have a pretty good selection of all these different framing devices. There was a page in your book, in your reading assignment. It's at the bottom. It was in chapter 3 and one of the things. It's just pictures of all these. So go check that out when you get a chance to. It's in your textbook. It's on the bottom chapter on your assignment for last night, but we've seen enough of this. You know, angle plates, all varieties of connections. I mean, it's infinite, but you have to understand it nowadays. Okay, everybody sick of that? Okay, so let's take roll and then we'll take a short break. So, Alec.
Here.
McLean.
Here.
Keenan.
Here.
Jose Cornejo.
Here.
Donna.
Here.
Diego Gomez. Enrique Gregorio. Enrique, are you here? Diego's not here. Hamar, are you here? Joseph's here. Colby's here. River Minocchio? River? Eric Mendez, you're here, right?
Yeah, I'm here.
Okay, Jack Miller. Dylan's here. Andrew Pacheco. He said he might have to work. Brandon, I saw you. Ishmael, are you here? Ishmael Perrin. D'Angelo, are you here? Alejandro. Cesar's here. Michael Silva. Jose Silva. James Stevens, you're here. John Tapia's here. Aurelio's here. Angel Vasquez, are you here? Angel? Okay. Okay, Dennis. Dennis is here. Braun, are you here? Okay. So, not the greatest attendance.
I think you missed my name, Patrick.
Who?
Hamar.
Oh, yeah, no, I called you. Thanks
Good.
for, I did. Thanks for checking in though.
Oh, okay. Yeah, no worries.
Yeah, great. Okay. So take a 10-minute break, and then we'll look at some videos, and we'll look at videos till we're tired. If people are just don't want to look at a bunch, we'll just look at a few. I've got a whole bunch because there's some interesting stuff. But anyway, take a little bit of a break and come back in 10 minutes, and we'll just look at some videos and go home. Okay?
Right.
Sounds good.
So, like 5 or 10 after 8.
Hey, Patrick,
Yes, sir.
what would you say are the 3 biggest local issues we face here in Santa Barbara currently? Politically, climate, whatever.
Uh,
I'm sorry, but
well, the pandemic's one, right?
yeah.
Yeah, I think that's the biggest one right now. Racism's everywhere. We don't have a lot of blacks in town, so I guess the racism would be with Hispanics. We don't have a lot of Jews, so it's probably mostly Hispanics, and that's always not good. But we don't hear so much about it, right? We don't have a lot of police violence against minorities. We'd have some, I think, but so that's a problem. But I don't know that it's it's certainly not as big as a lot of these bigger cities we're hearing about. And let's see what's left. Well, climate change, but God, the climate change is discouraging, isn't it? I mean, California, are fires up near where you're from, John?
Yeah, there's definitely a few up there.
Man, I mean, look at Oregon. People years ago said, well, let's move to Oregon because it's so wet, there's never fires there. And same with Washington. And look at, I guess that's not true anymore.
Yeah.
So I think, since you know me, hey, I just finished another book, John. It's called Can Humans Change? Wouldn't you know it? But, looking ahead, I know we hate to do it. We're just trying to feed our faces and keep our families together. But looking ahead, it may be inland California is not very viable, especially around the forest areas. Maybe we could keep the Central Valley, with the agriculture, we could keep that safe, and maybe the coastal towns, right? And we can make a little gap between us and the forest. Santa Barbara, we have to do a lot of work. But it may come down to that, let's face it, because it's not going to get cooler or wetter that we know of. It might, nobody knows for sure. We know there's big changes, but we're not sure exactly. People said this area is going to get wetter at one point, and then that's not happening. So I think fire's still going to be a big one, even down here. God, why, you got any?
I was doing the Independent had a survey for millennials, and they had a thing for local and national issues, and I think on my national it was
National would be racism for sure. Racism and
I think I had racism, climate change, and sexism. I think that those are my 3 for national.
Yeah,
and
always. Yeah, I mean the pandemic too, of course, but I mean those were yours. But yeah,
I wasn't sure if they meant long or short term. I wasn't.
Yeah. Well,
not the pandemic is short term, but
yeah, no, I know what you mean. We'll once we get the vaccine, hopefully it'll be sort of passed. But the racism is really serious, and it's really hopeful that so many people are speaking out and not stopping speaking out. I think that's just great. Maybe we'll finally do this. I hate to see what would happen if we don't address it. It's not going to be, people aren't going to let it go. I mean, which is great. And it needs to go from blacks to Native Americans to Hispanics to Jews in some places. All the groups have to be covered too. And then the there'll be, the gay community and trans community, including them. And I'm hoping it'll just be like a dominoes thing, and we'll start working with all of it. It'd be great.
I think overall, it seems like through history we have become better in these ways, and I can definitely see a path of progress to move on towards that, and I can certainly see the possibility. I mean, when I was a little kid, that everyone called gays pedophiles and stuff like that. Just 20 years ago, and now you don't quite hear that anymore. And
yeah, I mean, that's actually hopeful, and that's actually been happening. I mean, there's a few spots that are really still horrendous, where they're killing trans people still, but that has made a lot of progress. Misogyny, you put sexism, that still needs a lot of work, That's still, and it's like, I was talking to a friend today about racism, and I've been watching a lot of news in the last 6 months and a year, and I was surprised at how many articulate, educated Black spokespeople there were, whether they were professors or just people on the street. I thought, fuck, where have all these people been? And I all of a sudden realized how I've been duped by this, by just the news not covering that. And I live in a community where there aren't a lot of Blacks, for instance, although where I first lived in downtown LA, there were. So I just haven't had the contact, and I haven't kept aware, but that's just insulting that I didn't know that. I felt really almost embarrassed, But it's really nice to see people, of color that are every bit as articulate and passionate as the white, people here. And but I don't have a racist bone in my body in terms of doing something consciously against a minority or anybody. But I have been part of this white culture that has systematically, in many ways, kept minority people down. And so I'm guilty of that. And a lot of that's been just because I didn't know I've been sheltered from it. But I need to get out from under that shelter and start doing something about that too.
I've noticed, like, I grew up in Northern California in construction, and there people really hated Mexicans because they felt they were stealing their jobs. And that was a very normal part. Obviously, they weren't Mexican, they were somewhere in Latinx, somewhere. And I grew up, what?
Especially the Chinese. I went up there to a little Chinatown one time, and it's like I bought one of those little red Buddhas for good luck.
Yeah.
And this lady just like completely like snared at me, and I'm like, what the fuck? I'm like, just buying something from you. And she was just like looking at me like really, really bad. And I was like, I was just there with my girlfriend. Like,
was that woman Chinese?
Yeah, she was the owner of the shop. She had like one of those little shanty town, little shack things with like, all kinds of like Chinese stuff. And I'm like, and I was like, well, fuck, like, I guess I won't, I don't know. I don't like San Francisco. Too many homosexuals and too many hills. I'm more of a Southern California boy. I like Orange County, San Diego, Newport, all that shit.
Yeah.
I don't know. I've been up to work in San Francisco, and like, I couldn't wait to get the fuck out of there. I was there for one night, and I'm like, no, this is not me.
But John's not from San Francisco. He's from Northern California, but a little bit away from there. But if it weren't Mexicans and Mexican Americans taking jobs, it'd be other white people, right?
Well,
I mean,
people see a need to create carpenters and construction companies, and it almost doesn't matter, right?
The very worst thing is where I'm from, there weren't any Mexicans, and they just hated Mexicans. They weren't stealing our jobs. There's literally nothing. They heard it on Fox News or something.
Oh, yeah.
Like, it was only white people.
Yeah.
And the only, I mean, it was just a total thing, though. Everyone talked about it.
Yeah, yeah.
And I found myself, being like, oh, this, this Ricer with these rims, and even though we had the same cars and did the same shit, and I grew up around it, and it's not that I'm racist, but it's just like, oh, I'm used to that.
Yeah. So, that's what like at City College, they're doing a lot of racial education, for people like us who just didn't come from the area where a lot of this stuff was obvious or whatever. And a lot of white people, including myself, fought it for a while, saying, well, I'm not racist, and I'm not. I mean, I embrace pretty much all people. I love Black culture. I love Hispanic culture. I grew up in places where there were all these cultures, but I do participate in a society that has kept a lot of these cultures, down. And so I need to, not be a part of that.
I wouldn't say down. I would say more left out, like, because like keeping down, it almost sounds like you're doing way more, you're wasting more time and putting more energy in like keeping somebody down as opposed to like keeping, like, instead of like just excluding somebody. And you as an instructor, I'm writing an essay right now. I'm in my English class. I'm in my last English class. And like I'm writing about racism, about this Black guy and all this shit. So everything right here is relevant. And what I notice is like you are being part of, you as an instructor or teacher are helping everybody because you're including everybody, you're informing people. Back in the day, I'm going to be turning 30 years old this January. I used to ask a guy when I was working like literally as a grave digger, I was like digging fucking trenches, like backbreaking work. I go, hey, how do I get to where you're at? He was a carpenter. He's been in the business for a long time. He's like, oh, buddy, it's beyond you. It's like, don't even worry about it. Just keep doing what you're doing. He goes, he didn't want to fill me in. He didn't want to like tell me like, okay, well, you go to school. This is the way you do it. And literally it took me like 5 years to figure out like, fuck, I didn't know that there was a construction technology program. I didn't know that I could do this and that.
That's
it's actually
terrible.
a lot easier. Imagine if I wasn't proactive.
Yeah.
And learning, like literally, like I've always been the kind of person that overcomes things. Like I think it started with sports and football, like being a defensive like captain of the defense. It's like, no, fuck that. Like fuck everybody. I'm gonna do what I gotta do. So I mean, had I just listened to him, I wouldn't have been here. I wouldn't be going for my associate's degree, and like I would be stuck. So so whatever. So I'm not mad at them. People are like that. They're everywhere.
But I was looking at the news today, and there was it was the farm workers thing. They were talking about not just Mexicans, but the Indians from Mexico, right? The Native Americans that are working. We have a lot up here. Santa Maria's got a lot of indigenous people picking.
Speaking of Santa Maria, they're killing a lot of Black people in Santa Maria.
Yeah, but let me finish this idea. And she was, an Hispanic that was working to help farm workers, and she said, the interviewer said, well, don't they get information about how to wear masks and where to find masks and what not to do? And she says, no, none of it's given in Spanish. None of the handouts are in Spanish. That is so unbelievable. But that's an example of where that is putting someone down. That's not just a neglect. If you don't give them information, you're doing something to them,
But then there's the argument, this is America and everybody should speak English. And if you don't speak proper English, if you speak fractured English,
but
English,
I'll tell you something. If everybody who didn't speak English left this country right now, we wouldn't have any produce.
That's true.
I don't know what we'd be eating, but we wouldn't be eating nuts and produce.
When my great grandparents came here, they only spoke Norwegian. And moving down, my grandparents, they were pretty good English. And, finally, after 3 or 4 generations, I learned. But it takes time. And people want to associate with people of their cultures. Like my family, they want to speak the language. They want to have they do the different dances and stuff.
Yeah. I know. Well, what's interesting is, you reminded me, your grandparents are Norwegian. We think, oh, well, Norwegians, boy, there's a safe group, right? But no, in the Midwest, where the Norwegians settled, upper Midwest, there was a lot of anger about them, coming in, and because they weren't the first people there. They weren't even the Native Americans, but Anglos had moved in, and then you get these Scandinavians, and they're going, what? God, you wouldn't, I had a friend who grew up in Steelton, Pennsylvania, where Hershey is. When I lived in Maine, she was a friend of mine. And I said, well, what kind of, prejudice do you have there? And she says, oh my God, Eastern Europeans. There's a whole pecking order. You know, the Serbians and the Czechs and it's all, you know, they're all in a certain, I went, you're kidding. And then when I was in Maine, it was the French Canadians that were the, you know, the immigrant group. Everybody made fun of them, and I couldn't believe it. I said, French Canadians? Oh, God.
What about the Irish?
The Irish, God, in New York, and when they first came, oh, man, they were persecuted like crazy.
Yeah.
Nobody would think the Irish would get persecuted, right? But
I don't think they taught.
Yeah, they talk different. They weren't very educated. You know, they were fleeing the potato famine. They weren't educated at all. They were just like ignorant farmers. So everybody just hated them. You know, my ancestors, you know.
They're really hardworking, like, you know.
Well, they're decent people like all people, but
Yeah.
oh yeah, they had to, you know, all those groups have to fight to become included.
Mhm.
You know?
So,
Anyway.
Okay.
So I hope that helped your paper a little bit.
Yeah, well, I did my thesis and all that.
So, yeah, John and I could spend 3 hours talking about this stuff, and we have before. So let's get back to building. So let's see.
Hey, this is the most important part of building is becoming a better human being.
Yeah, I agree.
Whereas
No.
Rodney likes to say communication. Without communication or unreasonable people, you can't build shit, man.
Yeah.
Yeah.
Rodney fucking taught me that.
Well, you know, I'll tell you, the global warming, they thought it was going to go slower than it's going, and they found out it's going faster, unfortunately. But
Yeah.
you know, there's going to be huge immigration coming, right?
Who's next?
So far, we've been looking at political immigration. You know, people in Central America running from terror, and people in the Middle East, you know, trying to get away. But it's going to be weather related pretty soon. And say the whole part of California is unlivable. All those people in the hills and mountains are going to have to go somewhere. They're going to come to the cities. So this is not going to go away. This is a big thing. So it'll affect the building industry because we're going to have a lot more housing. We're going to have quicker constructed housing. The codes are going to have to shift to be not so stringent because it'll slow us up too much. So all this stuff is important to know. You know, the future. A little.
Many
bit
homes, man.
There's going to be all kinds of stuff. It'll be really. Unfortunately, I won't be alive for a lot of it. But you guys, it'll be the construction will be really interesting, and it should be a lot of fun actually.
So I was actually talking to somebody, sorry, but this is on topic, and you said how everyone's going to be coming down from the big ass hills at the very top of the mountain all the way down into the cities where the air isn't so shitty. And I was asking somebody, I go like, hey, where do you see the city of Los Angeles? Like, I look lazy. I said, where do you see the city of Los Angeles going with all these people leaving and moving into like the suburbs and stuff? And one person said like, okay, well, things are definitely going to get way more strict, but at the same time, Los Angeles or cities like that have such a strong soul and pride for their town that they won't leave. So, but a lot of businesses have shut down though. That's the thing, is like so much has shut down, and if people are working from home, then those people with all that money are not going to be buying like their other workmates like lunch or all these other smaller mom and pop businesses are going to go there.
We'll see. I want to cut this off here, but I'll just say one thing. I grew up in LA. I know a little bit about it, and it's interesting where that will go. They don't have a lot of room. There aren't. I was one of the generation that moved out to the suburbs from the central city, and there aren't any more suburbs. I mean, the crappiest suburb now, the houses are as much as Santa Barbara. It's unbelievable. Yeah. So I don't know what's going to happen there. And then there are too many people, unless they deal with the smog, the non-fire smog, it's still not going to be a great place to live. I mean, who knows? Maybe they'll deal with all that and but I think our population's too big, and that's going to have to go. You know, it's going to have to come down. It'll take a couple of generations to do. So we'll see. Okay.
You can't have a kid kind of thing.
Yeah, you know, it may come to that, right?
You don't make $100,000 a year, you can't have kids. If you do, we're going to kill you.
Yeah. Who knows? Well, what I'm trying to do is make,
I'm trying to get all communist.
no, I'm trying to make government local, really local, not even have national government, have local and regional governments. I've been writing about this and trying to get this going. And then we have control of our area and we do what we need to do. And people, if someone says, well, I think we got to not have any children, and 80% of the people say, bullshit, we want at least to have 1 or 2 kids. That's how it'll work. And that'll be fair, you know. But when it's national and we don't even know the people that are making decisions and they come down with a decision, you know, what's.
I think it's going to be hardest to police third world countries because, like, who's there to govern them? You know, they're going to do whatever the hell they want,
Yeah.
you know?
Well, yeah. Okay. So let me go to my my fabulous YouTube account. And share the screen. Okay. Is everybody got a YouTube page?
Yeah. Yep.
Okay, so let's do The Simpsons just to finish that up. So the first one is how to select a fastener. Let's see where the hell that is.
Hey, Patrick, are you going to get Matt Bangs Wood to be a guest speaker for the class?
Maybe.
He lives up in Santa Maria. He's a really cool guy. I've talked to him before, yeah. He lives in the city right north of Santa Maria. He's a really cool guy.
Oh, wow, okay. How to select a fastener? Yeah, let's do this one.
Simpson Strong Tie offers the most high-performance structural steel connectors on the market, and they're proven most effective when paired with our
Can everybody hear this?
Yeah.
Okay.
premium tested structural fasteners. Together, fasteners and connectors create a system that helps ensure the strength of your connections and the safety of your structures. We provide fastener recommendations for all of our connectors. Variables such as application, environment, and load requirements all play a part in how we determine the appropriate fastener type, length, diameter, and finish. Be sure to match the metal and finish of your fastener to that of your connector. For example, if using stainless steel connectors for corrosion protection, use stainless steel fasteners. Some connectors require a fastening method called double shear fastening. To ensure you're using the right length fasteners to penetrate both the joist and header, see our specifications. It's important to consult our wood construction connectors catalog, website, or the installer's pocket guide to determine exactly which fasteners should be used with your connectors. Find the right Simpson Strong Tie fastener for your connection at strongtie.com/connector fastening.
Where did I go? So, how interested are you in seeing how these joists and things are actually done? I've got a film. Let's see how long that is. Let's see what time it is. Everybody's probably getting tired.
Yep.
So we don't have to look at, we've got time in other units where we can come back to this. So this one is 12 minutes. Is that too long?
No, that's fine. We'll just watch one.
Yeah, that sounds good.
And then there's this is a hold down. That's kind of funny. It's a New Zealand guy. Anyway, this is really good. So let's at least look at this one and then we'll see where we are. Now, is that on the screen?
Yeah.
Yeah.
Beautiful.
Okay. I used to show this in class. I had a little
Simpson Strong Tie,
DVD, but now
connecting
it's
your
online.
house, your
Great.
home, your life, making your home stronger, safer. Connectors that make construction faster, easier, and more economical. For dealers, builders, designers, contractors, and homeowners, we connect lives, homes, and people. The strongest ties to a well-connected house.
Hello and welcome. Simpson Strong Tie leads the industry in product innovation, quality, and technical support for structural connectors. In this short video, we'll cover the basics for correctly installing Simpson Strong Tie connectors. Effectively utilizing these connectors not only makes construction more efficient, it creates a stronger, safer, well-connected structure. First, making a good connection requires having the right connector. Right connector should be chosen by your architect, engineer, or designer. Our job is to be sure that it is installed correctly. And once the correct connector has been determined, the single most important factor in correct connector installation is the proper use of fasteners. So let's take a look at some of the fastener types we'll be using with Simpson Strong Tie connectors. Depending on the kind of connector chosen, you may use nails, machine bolts, strong drive screws, or Titan masonry screws. But it's more than just the type of fastener that's important for proper connector installation. So let's look at the most common fastener used with Simpson Strong Tie connectors, the nail.
There are many different types of nails, so make sure you're using the correct one. Fortunately, most Simpson connectors have the required nail stamped right on the product. But if you're unsure, simply refer to the current Simpson connector catalog. Although two nails may look alike, there are three key features of a nail that will affect the performance of a connector: diameter, length, and finish. The diameter of the nail shank, often referred to as the gauge of the nail, affects the shear capacity of the nail. The thicker the nail, the more shear resistance provided. So be careful. Substituting a nail with a smaller diameter shank will reduce the load capacity of the connection. Here are some common nail types with their associated diameter and wire gauge. The length of the nail is the next most important factor in determining the connector capacity. The reason is simple. Nails must have enough penetration into wood to achieve full shear capacity. Here are some common nail types with their associated lengths. Some connectors require full-length nails and cannot use shorter versions. Examples include hangers with double shear nailing and some heavy top flange hangers like the HGLTV. For other products, substituting a shorter nail will result in drastic load reductions. Never use short nails without first verifying whether they will work. Here are some common nail types with their associated minimum penetration lengths. And keep in mind, when using our patented double shear nail hangers, you must use the specified full-length nails. And finally, consider the finish of the nail. Galvanized or stainless steel nails may be required for corrosion resistance. Check with your local building department for specific code requirements. It's important to realize that many of the nails found in lumber yards are not appropriate for use in connectors. Examples of these nails include drywall or sheetrock nails, roofing nails, and small common nails like the six-penny nail. These nails lack either the length, thickness, steel composition, or coating needed, and they substantially reduce the load capacity of your connectors.
Remember, the incorrect use of fasteners is the single most common mistake made during connector installation. Now that we're aware of the importance of using the right nail for each connector, let's spend some time talking about installing those nails. Metal claw hammer, still the tool of choice.
But palm nailers can also be used and are a great way of reducing installation time when used with the correct bag nails. Some pneumatic nailers can also be used, provided they have nail hole locating mechanisms and they use the correct nail for the connection. Do not overdrive the nails. The nail head should be seated flush with the steel. Keep in mind, though, that most standard framing nailers cannot locate holes and therefore should not be used to install nails into connectors. And furthermore, since most collated nails for standard framing nailers are undersized, they should not be used to install connectors.
Now let's talk about screws. Since screws act differently than nails, they cannot be interchanged.
Screws are often tempered, which makes them brittle, and therefore will not yield the shear strength that nails provide. Examples of common screws not suitable for connectors include drywall screws, deck screws, and lag screws. But Simpson makes a patented screw called the SDS, or strong drive screw, that is code listed, needs no pre-drilling, and comes with the connectors that require them. But beware, do not mistake an SDS screw for a lag screw. A lag screw will not achieve the same loads as an SDS screw and is not allowed with Simpson strong tie connectors. And finally, for those connectors designed for use with masonry screws, remember to pre-drill those holes, the required diameter and depth for correct installation. The drill bit diameter can be found on the packet of screws, and it must be drilled at least 1/2 inch deeper than the screw length.
Now let's talk about machine bolts.
They should of course be pre-drilled to a diameter only 1/16 of an inch larger than the bolt itself, and they require a washer on the wood side of the connection. Carriage bolts, lag screws, and all thread rods cannot be used in place of machine bolts. It's important to remember a pre-drilled hole that's too big for the bolt will compromise the integrity of the wood and make for a weak connection. Since repairs for poorly drilled holes can be costly, make sure the drill bit is of the right diameter, it's not bent, and you drill the hole from one side. Don't try to meet the hole in the middle by drilling from both sides.
You've probably noticed that Simpson Strong Tie has different shaped holes throughout its product line. You'll see round, oblong, triangular, diamond, and hexagonal shaped holes in our connectors. But what do these different hole shapes mean? Well, each different shape indicates a different fastening requirement.
The most common shape is the round hole. This hole must be filled with the fastener type specified. The only time you may not fill a round hole are for straps and strap type hangers. These products have more holes than are required to allow for multiple fastening capabilities. Oval or oblong holes are simply used to provide easier access in tight locations and should be treated like round holes. As a general rule, all round and oblong holes should be filled with the appropriate nail. Triangle holes are used for increased capacity and must be used if specified by the designer. Connectors that have triangle-shaped holes have a minimum and maximum load value. To achieve the minimum load value, you must fill all round holes. To achieve the maximum load, you must fill all round and all triangular holes. Diamond-shaped holes indicate a temporary fastening option and are there to aid installation. It is not required to fill diamond-shaped holes. Hexagon-shaped holes are used exclusively in conjunction with our Titan masonry screws, and these holes must be pre-drilled.
Along with different hole shapes, Strong Tie connectors use a variety of innovative design features to help secure their connectors with greater efficiency and more precision. The most common of these are the patented tabs and domes.
Both of these features force the nail at a 45-degree angle, providing correct installation of our double shear nail design and allowing for a much simpler, faster, and stronger hanger installation. Simpson also uses this 45-degree feature with engineered wood product connectors, commonly known as I-joist hangers. This application is referred to as PAN, or positive angle nailing, which actually forces the nail into the wood at a 45-degree angle, minimizing wood splitting problems. Other I-joist hangers feature a bend tab that locks the hanger to the bottom chord of an I-joist, which prevents joist movement and therefore minimizes squeaks in the floor system. Simpson's newest design, the IUS, features a snap-in seat requiring no joist nailing, the fastest possible installation and huge labor savings. Speed prongs are another strong tie innovation found on many of our connectors. Since it can be difficult to hold a connector, hammer, and nail all at the same time, these handy prongs are used to temporarily position and secure the connector for faster, easier installation.
Now that the connectors are installed, it's a good idea to check your work. First, verify that all the appropriate holes have been filled with the specified fasteners.
If this has not been done properly, it could result in a premature failure of the connection which may create a life-threatening condition. Once you have determined all required holes have been filled, check both parts of the connection to ensure fasteners are installed into appropriate material, like lumber or masonry, and not into thin air.
So let's take a moment to recap what we've learned. First, we know how important it is to verify that we have the right connector for our construction plans. Second, we learned how important it is to use the proper fastener for those connectors. We learned that nails must be the correct length and diameter. And don't forget to check local agencies for any special corrosion considerations.
For screws, we know that Simpson Strong-Tie offers two types of code-listed structurally rated screws, the SDS screw and the Titan masonry screw. The SDS is code-listed as a self-drilling screw, but remember, a lag screw is not an acceptable substitution for an SDS. And because of the base material, it is necessary to pre-drill for proper installation of the Titan masonry screw. We also learned that machine bolts must be pre-drilled to a certain tolerance, and that a carriage bolt or all-thread rod may not be substituted for a machine bolt. In addition to the proper fastener, we know how important it is to use the correct quantity of fasteners. We learned the significance of all the different hole shapes and design features, each representing a different requirement or feature. We learned about innovative features like tabs, domes, pan nailing, and speed prongs, all designed to aid in proper installation. And finally, Simpson Strong-Tie connectors can only be as good as the base material to which they are fastened. Make sure that the material is suitable for fastening and will support the load developed by the connector.
After all, Titans, SDSs, and nails can't work if they're not fastened into adequate material. If you're not sure or it's not stamped directly on the connector, remember, all fastener types and quantities can be found in the current Simpson Strong-Tie catalog or on the web at www.strongtie.com.
Welcome back to the Simpson Strong-Tie product highlight. Today we're going to be talking about our hold downs and tension ties. So the standard hold down that we use in the New Zealand industry is something similar to this. But let me tell you, this is not a hold down. This is a hold down. Here at Simpson Strong-Tie we have a full range of hold downs for standard residential, heavy duty commercial, and seismic strengthening and upgrade work. Right, so let's run through the range of Simpson Strong-Tie hold downs, starting with the DTT2. The DTT2 is available in zinc and stainless and used in standard residential applications. It's used with single or double studs, is installed with our SDS connector screws, and also our Titan HD screw bolt. So next in the range we've got the HTT4 and HTT5. The HTT4 and HTT5 are personal favourites of mine. It's such a universal bracket and can be used in many different applications. It's been used in residential, commercial, sub-diaphragm floor and ceiling applications, seismic upgrades. It's just a really good bracket. It's one piece of metal which has been folded back on itself, so there's no weak points with welding. It's also got a unique nailing design which gives it extra strength. It can also be used with threaded rod or our Titan heavy duty screw bolt. Finally guys, we've got our HDU8, it's our ultra heavy duty hold down. This has been pre-deflected during the manufacturing process, which basically eliminates stretch under load. It can be installed with SDS heavy duty connector screws and once again a THD Titan heavy duty screw bolt. Thanks for joining us on our presentation on hold downs. Don't forget guys, all the information is available at www.strongtie.co.nz or get in touch and we can arrange to have the literature sent out for you. See you next time.
Dub, dub, dub.
Dub, dub, dub.
You caught that too, huh? Okay.
Oh, man.
Hey, come on, you guys. You
Dub,
know what that?
dub,
You know what?
dub.
You know where that scene was? This isn't a hold down. This is a hold down. Crocodile Dundee.
Yeah.
Anybody see that? The guy, this guy steals a purse and he throws a can at him, and then the guy draws a knife and he looks at it. He's got a little knife and he says, "Ha ha, that's not a knife." And he pulls out this giant Bowie knife and he goes, "This is a knife."
Yeah.
That's what that was from. Anyway, New Zealand, he's borrowing an Australian thing. But so, yeah, so I think that's all we're going to do. I've got a ton of other videos. They're short, but I think we're tired. But, you know, we'll integrate them into the next lessons. There's always time. I'll tell you what I got, though. I got some framing ones and layout that will reinforce what we did tonight. Those will be good. Also found one on how they make plywood from logs. Haven't you all wanted to see that?
Plywood from logs.
Yeah, it shows an old one and then it shows one in Finland today. Great footage. It's really cool. And then I've got one on a shake test because we've been talking about seismic. Simpson went to Japan where they had this giant platform and they built a 4-story apartment building on it, and they shook it, you know, to mimic an earthquake. It's not very long. It's really cool. I'll show you that at some point. And then there's the Forbidden City in China. You know, that old where the emperors used to, in Beijing, where the emperors used to use. They did a facsimile of a little temple. They built it at a smaller scale, and they did a shake table, and they showed how the way it was designed, the brackets and all the wooden gewgaws and stuff, how it actually kept it from falling apart. That's a totally cool video. It's not very long, so I'll fit those in someplace too. Anyway, I won't have a, I've got to think about the question for the group discussion. So I'll either do it tonight or check back tomorrow. If I'm too tired, I'll do it tomorrow morning. So go and do that. I saw what you guys did on the last two. They were great. I want to say one thing, one comment. Somebody said that 16 on center is better than 24 on center because the walls, I don't know, the floors squeak less or something. I can't remember. But they use 24 on center with 2x6 walls where they need more insulation. And you could use two 2x4 walls, a double wall, or you could do a 2x4 and put a shitload of rigid insulation on the outside. But in northern climates, they all build with 2x6 at 24 on center to get a lot of insulation in there. So just to answer that question. But they were good. You know, you guys are starting to get the idea of the blog. I liked it. So I'll have that topic, start that tomorrow morning. I'll have this video ready tomorrow morning if you missed any of it or some of you weren't here. Otherwise, do your reading for next week, yeah? We're going to start citing, you know, and this is something we do in class. You know, even in the Simpson Strong Tie, I could show you our nail guns, the ones that are used have the nail sticking out so they don't, if you don't have one that has that's dedicated to that, you don't know where the nail comes out and you'll just be shooting a nail into metal, which is not a really great idea. But some of them are made with when the nail sticks out and you can place the nail head into the hole and shoot it. And palm centers, I have all those at school, but if I get industrious, I may make a video at school showing those things. I don't know yet, depends on what. But so we'll do siding, and we'll start with fiber cement siding because that's real common now, and wood siding. I worked in Maine for 10 years, and the horizontal siding they call clapper, they're the ones who invented it. Well, it probably came from Europe, but they were the first ones here to do it, and they are masters at doing it. And Californians don't do it as well. And I'll show you, you know, the right ways and the less good ways to do it. California is always in a hurry, so we don't always take the craftsman-like way. And then the next week we'll go into shingle siding, which is still good, even though you have to use artificial shingles in fire zones. but sometimes you'll have to replace shingles, so it's good to know how to do that. And then we'll do board and batten, same thing. There's a community near school, Wake Center, the whole development's done in board and batten. I used to take my classes up there, but I can't right now. So that's good if you want to replace that. And then there's actually plywood people who still use for siding for sheds and less expensive buildings. So we'll do a thing on siding. Then the week after that, October 5th, that's kind of got a bunch of throwing in stuff. We'll do some of the stuff we missed tonight. We'll especially have time that week. So great. So I know this stuff's kind of technical, some of it, but it is an advanced class, you know, and we don't want to hold people up, so we let everybody into it. But so for you beginners, if some of it's confusing, you've got a great book. Go back and, you know, educate yourself on framing. Just read more of the chapters and try to catch up. And then I'm here 5:30 every day. If you have questions, make a list of questions and get on early and ask me those questions. Or even if it's a question from 2 weeks back, ask it during the lesson. I don't, you know, it's better if you ask questions and we get into a discussion. It's less boring than me just hammering away. So tonight was great because you guys had questions, and also people challenge me in a good way. They say, oh, they're not doing that, or, you know, we do this, which I want to hear, because people do things differently. I haven't been in the field for 10 years. So sometimes I'm behind a little bit. That's why I often have you consult Jim, because he's still in the field building, so he knows the local codes at the tip of his fingers. So I try to stay up on it, but you know, if you're not in the field, you miss things. But I do know the basics pretty well. I've been doing this for 50 years. So we're learning a lot of, you know, tangential things, but they will pay off. They're really good if you're going to get into this. They'll help you work faster and figure things out better. Okay, any questions? You all good?
Your office hours are basically every day from 5.
Well, they're 5:30, but if you have personal stuff that you don't want anybody who might be on there, or you have more, email me and say, can we get a half hour or an hour somewhere? We can't meet in person yet, but I can set up a Zoom even individually, or we can do it by, you know, phone or whatever.
Sounds cool.
But yeah, you can get a hold of me. It doesn't have to be that half hour. If you want more privacy or there's a personal issue or whatever, email me and we'll set up something. Yeah,
Hey,
good.
Patrick, do you have a couple minutes after class today?
Yes, yes, I'll stay after. Okay, so that's it, everybody. Thanks for your participation, and I will see you next week. Same time, same place.
All right, Patrick. You have a good one.
Okay, guy.
All right, Patrick.
All right, everybody.
Later, Patrick.
Thank you.
Yeah, you're welcome. All right, see you all next week. I'm going to stay a little bit for John or anybody else who wants to stay, but.
It's not super personal or anything, but
Okay.
you won't hurt my feelings too much.
Well, I'll tell everybody to get off if you want to have it private. So, but otherwise, so you know, they probably need to go anyway. But anybody's welcome if nobody says opposite. So, what do you got, John?
So I know I've been a little behind on the group discussions.
Yeah.
I want to apologize. I'm getting married on Wednesday.
Oh wow.
Yeah.
That's great.
So it's
pandemic marriage. Wow.
Yeah. So
I got married in the pandemic of 2020. Cool. Cool.
Obviously the wedding part of it was canceled, but
yeah.
No, we're going to the courthouse on Wednesday, and
yeah, and then do it when this is all over. Do another one.
Yeah, no. So I caught up today, but I've been a little behind with pretty much everything.
No, don't worry about it. I don't worry about you.
Work has been crazy, but on Saturday morning I missed James' class.
Yeah.
I totally passed it out.
Well, you know,
and apologize, and I know I emailed them today.
Well, see, that's all you got to do is
yesterday,
just be honest and communicate. I mean, we're human beings. Plus, we've been ordered by the administration to go easy on you guys.
Oh, really?
Yeah. They said
Oh,
it's a
good.
fucking it's a pandemic, you
It's a
know?
fucking
Everybody's
pandemic,
got all
man.
kinds of problems. We're all
Yeah.
depressed. We're around our kids too much, you know, and our wives too much. I mean, you know.
Yeah.
So, yeah, so we're open, you know, we're understanding. And we have a good nose for smelling when it's being abused, okay? So we'll draw the line, we'll say, But
I promise not to get married again anytime soon.
well, congratulations, John. I think that is
Thank
great.
you.
I'm really happy for you.
Dude.
Yeah, super.
So what's his name? I'm just kidding, John. I'm just kidding. You say you're from Northern California. I'm just messing with you, bro.
Hey,
Joe.
we gotta work on this guy.
You know your dad is my neighbor right now.
You serious?
Yeah. No, he just did a job for me last week.
Are you serious?
That's great.
Yeah.
That's great.
He's
Wow.
my neighbor. He lives right around the corner behind my house.
I had no idea.
Yeah,
really
no.
funny.
I've seen his trucks for years, and I was like, Jasso. And the other day we were talking for this job. I was like, you have a son named Joe?
So you're over there on Walnut off of
Yeah.
Yeah, I live on San Ramon, the second house in. I have remember my brother's old Tundra? The big white Tundra? I still have that.
Yeah, you're
Always parked out front. I got that in a work truck.
That's funny. So yeah, so Joe, you have more connection than you think.
That's awesome.
Yeah.
You better be on your toes.
Yeah, no, my dad's really busy. My dad, you know, he's really good at like getting trench work done, like a lot of that heavy duty shit that nobody wants to do along a fucking hillside, like a goat kind of thing, you know.
Yeah.
He'll get that stuff knocked out for people at a
It's
reasonable
great.
price.
You know, there's a need for
And,
that.
like,
It's a
a
niche.
little while,
Yeah.
yeah.
I
Most people don't want to do it, and he's like really reasonable.
I had these
Go,
friends
John.
with this rental property, and they had a shower that was leaking. So I replaced a bunch of the shower, and I got a tile guy in to redo the tile. I did the exterior, but I had to pull the whole thing apart, and I couldn't find anyone to do a stucco. And I called 3 stucco contractors I know, and none of them did it. And I called your dad. Actually, I went over there with a beer, gave him a beer, and he's like, "Hey, can you come by and get your guys to come do this?" And he showed up next week and finished it before the people moved in. No, he did a great job.
Wow,
It was
that's
amazing.
great. Yeah.
That could help you out, man.
He saved all of us so far.
That's
It
great.
was-
Yeah. You know, there's a bunch of people in town that are really trustworthy, and they'll bend over backwards to fit you in because you're, you know, a client. Those are the
That's
people
why-
to cherish.
Yeah.
I
That's why,
go ahead.
That's why Gavin, the president of Capital Pacific Development Group, like, you know, him and my dad, they have their own discussions, but Gavin is always just like, you know why I always use Jose? Because he never says no. 12:30 at night,
Yeah.
someone's main drain is clogged. He'll go over there and he'll get it done and taken care
Yeah.
of so that they can have their house working.
Those people will always have work because that's half the battle. If people can trust you and depend on you, that's half of it right there. And you know, people don't figure that out, or they don't have it in them to do that. But I
Well,
tell you,
There's a bad part too, because I told your dad it'd help him wire up his hot tub like 2 months
You got a fucking hot tub, bro?
You
I
got
didn't even know you had a hot tub.
like from this Russian oligarch guy, dude. It's like a swimming pool. He's like, "Hey, I got the wire. I just need a little bit of help. Finish it up. You do electric work." But yeah, no, I do a little electric work. No problem.
40.
It was like 2 months ago. And I was like, "Oh yeah, I'll come by next week or something." But I've been working every weekend with school, and I feel horrible. He showed up for me.
Oh shit! Don't worry about it, man. No, my cousin's an electrician. He works for Taft Electric. He's in the electrical union, and he's working his way up the ladder. I mean, I'm sure Moses can go over there and give him a hand. You know, so don't feel so bad. You know,
It's just a little bit of conduit. I'm gonna try to do it Tuesday morning if I can. It just needs a little bit of conduit bent and done. It's not a big deal. I'll go over and finish it.
Yeah.
But yeah, no, your dad and we were talking about this job. I was like, Jasso.
Yeah, there's not many of us that we're all related in some